Hey folks, welcome back to another video. Today we're looking at question 500, keyboard row. The way we'll be solving this problem is basically using a hash map to store all of the characters that we see in in the keyboard to a hash map that maps to the row number that it's a part of, basically 1, 2, and 3. And once we have that hash map ready, we'll iterate through all of the words and then we'll assign like a row thing that matches to the first character and iterate through every single character in the word. And if the character doesn't match the row that we pull out of this hash map, that means it's not necessarily like it cannot be typed using the same row, therefore it's not a part of that list. So we don't add it to the list. If we have reached the index all the way till the end, we do add it to the return list. And in the end, once we've done the for loop, we return the list. It's relatively simple, so let's get started. So we need a hash map of integer, and then let's go, character integer, character integer, a new hash map, and let's create this. Add character rows, and then let's say like a helper method, and then let's just send map to that. We create a void method here. This can be more descriptive, but it's fine for now. A hash map of character and integer, and we call this map, right? So let's do, we could basically have like a very long for loop that literally goes through every single character. Instead of doing that, let's create an array so that we reduce the number of lines. A new char array, and then this will have q, w, e, r, t, and y, u, I, and O. O and P. And we do the same for other rows as well. So we just grab this. So this will be C2 and this will be C3. We have A, we have S, D, F, G, H, J, K, and L. While I'm typing this, I wonder if so all of the words that are given to us are not necessarily lowercase. So the thing that we could do is when we're comparing the words, we could convert them to lowercase and then compare it so that it's easier and we don't have to add duplicate characters to it, or we could possibly add like the caps version of them as well. It's fine. C, X, C, V, B, and M. So this takes care of the the lower row as well. And can we make sure that all of them are characters, both lowercase and uppercase. Okay, cool, awesome. So we don't have to worry about numbers. So for character C in C1, map dot put C and C and 1. I wonder if we can add the caps as well by doing this. So let's see if this works. So basically what we're doing here is we're trying to add the capitalized version of the character to the map. Yeah, I think that should work. If not, we'll try another way. So this will be all the characters in C2, and this would be 2, and this would also be 2. All the characters on C3, this would be 3, this would be 3. Let's just double check that I have it right, because usually when there's a lot of typing like this, I could have easily missed something, and debugging that is relatively harder. Like the characters look to be okay so far. Okay, cool. So here we're adding all C1, C2, C3. Okay, cool, sounds good. I think we're good in this case. And we'll have a resultant list. So let's call it string res new array list. So for string word in words, intro equals word actually map.get word dot character at 0. So basically what this is saying is that, okay, this is a row for the very first character that we have, and then for int I equals 0, I less than I less than word dot length I plus plus. So if let's do the not case. If map.get word.character at I, if it is not equal to row, then we just need to break out of this and we don't really care about it. And the other thing that we need to do is if I is equal to sorry, I just see this typo. And if I is equal, when it's at the very end, is equal to word dot length minus 1, and the character is equal to the row, that means we have reached all the way till the end, and all the letters in that word can be typed using the same row. Then you would add that to the result dot add word. So this for loop right here takes care of adding all of the words in the list, and the thing is we should have been able to return it as is, but it needs a string array. So let's do that. String, let's call it str new int new string array, and then the size would be list.size. Yeah. And then for int, let's just initialize this outside. Int I equals 0. So for string s in result, str of I, increment I after it's assigned, is equal to s, and then in the end you return the string array. That was a lot. Let's try compiling this. Hope it works as is. Okay. Couldn't find symbol. Oh, this is what I was trying to do. Okay, let's try that again. Result word.length cannot be converted to. Okay, so this is, since it's a string, what are the other things? Oh, and this is result.size. Oh, right. And then you need to convert these to characters. Let's see if this works. Char of this. Let's try. And this again. Okay, let's try that again. Okay. I guess we need to put this in parentheses as well. I think this should work. Let's try that again. Ooh, interesting. Is null. Okay. Wait, I wonder, I think it's coming from caps. Like if you do it like a test case, let's do a test case of, how do we add our own test cases? Okay, can we edit this? We remove this and then we remove this, yeah. I think it should work for just lowercase, let's see. Yeah, okay, so I think it's the uppercase that's the issue. Let's try OMK. Let's try that. Okay. So I think it's the uppercase that is the problem. Alternatively, what we could do is the word, we could, yeah, just get it to lowercase. The string word is equal to w.to lowercase, and let's try running that to see if that works. Okay, that works. I wonder why this didn't work. They should have added uppercase letters too, but it's fine. Let's try erasing that. Okay, so the first few test cases passed, do they? Wrong answer. Oh, right, okay. Add back W. Let's try that again. Okay, that's awesome. So let's talk about the space and the time complexity. The time complexity of the entire solution is n into m, here where n is the number of words that we have to go through, and m represents the number of characters in that word, since we are using two for loops here. One for the word and one for the characters in the word. And then space complexity is of n, since we are using a hash map. Well, actually, because of the list. The hash map basically takes constant space because we're not necessarily adding to it. It just stays constant right here. Amazing. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I'd really appreciate it.